Yes, hello everyone. Jambo, I hope that's right. My name is Ambrose Ahura. I'm from Uganda, from Simplify Networks. First of all, a very warm welcome to each and every one of you in the audience from Simplify Networks. I'm going to be talking about load balancing and failover. Now, RouterOS is, what I love most about it is that it's very, very configurable, and it enables you to run about as many internet connections as your device that you have can support. So basically it could be a tether from your MiFi device, a tether from your Android phone, a fiber connection, anything really. Let me talk briefly about Simplify Networks. We are the largest distributor of router board devices in East Africa. We do offer solutions for enterprise, Wi-Fi, point-to-point, point-to-multipoint. We do security, we do power, we do cable, we do everything basically that you might need as an ISP or a WISP. We have offices in Kenya. We also have offices in Uganda, that's where I'm from. Then soon we shall be spinning up in TZ as well. So feel free to, we also have a booth outside, so you can talk to any of the guys with a Simplify shirts. Briefly about myself, I was introduced to RouterOS by a gentleman in the audience a few years back at university, and I've not looked back. I also like its PHP API. I find it, again, very configurable. So the agenda is I'll be talking about load balancing first. Then later on, I'll also talk about a portal that we are pushing out today from Simplify Networks. This is something that will help with we realize most of our customers have challenges with blocking sites, and they complain that it always so complicated. And I know someone from MikroTik gave an update about the TLS matching and stuff, so we welcome that. But we came up with something that basically it's a click-based tool to block stuff. We shall look at that in a bit. So, like I said, with a RouterOS, you're able to get several WAN connections and make sure that your clients enjoy the fastest speeds possible, whether you're an office, whether a hotel or apartments, whatever hotspot provider. And the motivation for load balancing is that here in Kenya, as the few days I've spent here, is that I've realized the internet is slightly better. You guys have much better speeds, probably because you're closer to the coast, and that's where the undersea cables have landed. But back in Uganda, the situation is quite different. Most of our average connections, the ones that the average person can afford, 2 MB, 4 MB, 5 MB are shared. And on top of that, they're not always on. Once in a while, you get a shutdown or service break or something. And then a lot of companies that require that you're always online, you need the aspect of failover so that you have one link and it goes down, you switch over automatically to another one. Then of course the high throughput case, and then the cost considerations, it may be cheaper to buy 5 than buying 10 or 20 at once. So RouterOS has got several options of how you can do the load balancing and the failover, and I'll go through briefly just to paint a picture. We have what we call ECMP, that is equal cost multipath routing. So basically what that does is it divides up the traffic into, according to source address, destination address pairs, and basically tries to send some traffic in one gateway, another in another gateway. Now, there's only one shortcoming with that mechanism, is that occasionally, after some time, routing tables get flushed. So when they get flushed, you may have a scenario where a request that came in on 1A gets replied through 1B, and that can cause a mischief. So the first option works, but has that shortcoming. Then the second option that's there is the nth load balancing, and that tries to change this shortcoming. Here we have, in this case, we have something called persistent user sessions, where you have the same, basically the same pair we try to make it persistent. Remember there it was being flashed, so we try to make it persistent here so that we avoid that mixed up in the replies. Then the option that I've looked at in my presentation is the PCC, which is a per connection classifier. And basically what this does is splits traffic into streams. So different streams then go to the different gateways of your WAN connections or internet connections from the ISP. So how this does the splitting is that you've got what they call an algorithm, basically a bit of math in the background that takes some options. So the options are the destination address, the destination port, the source port, the source address. So they take either a pair of those or a combination of any of the four and use an algorithm to divide up your traffic in a consistent way and have streams come out and then guide those streams to the different ones. And the way it works is that you have a kind of a modulus operation. So say if I have two WAN connections or two internet connections, what happens is I could choose to say, let me use both addresses and both ports. That means both destination and source address, both destination and source ports. And then my algorithm will be that we want, I'll have a denominator, then I'll have a certain reminder. So if I have two internet connections, then I'm working with two, and then my denominator can only be a 0 or a 1. So basically you'll have a reminder of, if the modulus operation works in a way that if you divide, say, a number of 2 by 2, you'll get a reminder of 0. Then if you divide the 2 by 1, you'll get a reminder of 1. If you divide 2 by 3, then you start getting fractions, and we don't use fractions in this per connection classifier aspect. So we shall only use a reminder of 0 and 1. So each time you classify that, you label the resulting traffic and give it a stream name, stream 1 or 1.1 or 1.2 or whatever you want. We shall look at it in action in RouterOS. This is basically a graphical representation to make it all simpler. So you have packets flowing into your router and then the outputs into the different ones after the splitting around there. So what would you need to basically configure this setup? Obviously you will need more than one, Obviously you'll need more than one internet connection. Then your LAN should have some IP address of sorts. And then the router OS you have should be greater than this. So I don't expect you anyway to have something as old as that right now, so you should be quite up to date. This is a setup I had in office back in Uganda. So I was using an LTE kit with a SIM card, and then I was using the office internet as well to load balance on a 2011. So let's look at briefly the configs that you require. So the first things first, you have to put IP addresses and name your interfaces. So that is self-explanatory. Then down here, we want to accept traffic into the pre-routing chain. So the pre-routing chain, like you hear pre, so it's before routing. What should be done to the traffic before routing? So if you want to manipulate traffic before you route it, you need to have it in the pre-routing chain. Okay. Then one important aspect is labeling traffic. So if you've got two internet connections, there are two things that will happen. You'll get a public request from, say, internet connection 1. So when someone in your local network is trying to reply to that public request, your router should know that I need to reply this through the connection through which it came. So to do that, we do what is called mangling. Now, Mango is a feature in the firewall menu. And what it does basically is it matches traffic according to certain matching criteria, which chain is it? In this case, it's the input chain. That means coming from outside, coming into the router. Then the interface, which interface is it coming in from, which is what we had called 1.1. And then the action. And the action was saying that mark that connection. So when we mark the connection, we call it 1.1 connection. So the router will always have keep track of connections that are originating from 1.1 or gateway 1, or whatever you have called it. These are the equivalent rules down here. So the same is done for the second internet connection. You could do it graphically or using the terminal. Then after that, we go to the actual PCC rules, the per connection classifier rule. And the chain here is pre-routing, so that's why we're accepting that traffic into the pre-routing chain. And then we want the interface, so the interface can change depending on your setup. And then now, down here is where the modulus operation is happening. So if I have 2 and a remainder of 0, I want to label it 1 connection 1. So another one would say if I have 2 and a remainder of 1, if I have 2 divided by a number and I have a remainder of 1, I want 1-2 connection as the label for that for that connection. So now I've labeled my traffic. The traffic, first of all, that is arriving from the public, from 2 ISPs or from 2 gateways that is incoming into the router. I've first of all labeled that. And then the traffic that is leaving my local network, going outside, I'm also now labeling it, because remember, the one that is originating from my traffic, from the local network, initially there's no way to label it. So we just have to break it up into streams using this rule, and then each stream is represented by this mark, or this connection mark. So this is again the command line version of that graphic. Then now, the next thing to do is make sure you do what is called policy routing, and that is basically using routing marks in RouterOS. So you get the connection marks that you made, the 2 connection marks that we've made in the previous steps, and then use them to make sure that a connection named X gets a routing mark named X, and the connection named Y gets a routing mark named Y. And we're doing this in the pre-routing and the output chains. And the complete setup now in the Mango chain will have a feel like this. And as you're setting up, you should see some rules register some traffic to know that you're on the right track already. Then to get internet, obviously, you'll need something like a masquerade rule, unless you have a public IP or something. You'll need, yes, when you have a public IP and you have a bunch of local IPs in your LAN, you'll need the masquerade rule. So you'll need to source NAT to make sure that your clients can browse. And then finally, you'll have to go to the routing table and sort out the gateways. So the default routing table will involve the ones here that have 1.1 reachable 1.1 and reachable 1.2. Those are the default. And then the policy will come in when you have the routing marks. So you can see it's basically using the same gateway, only that the traffic that is being sent to 2 has a routing mark of 2, and the traffic that is being set to 1 has a routing mark of 1. So we are sorting our traffic to 2 gateways and making sure that the right traffic goes through the right gateway. Then these 2 are very important, because should anything happen to these rules, these ones kick in and you're not offline. As a checkup to see that, to confirm that what you did is actually accurate. You check out the connections in your firewall, IP firewall, and you look at the connections. So as you can see here, you'll have each, because the different clients in your LAN, the computers will make connections to different servers out there, to Google, to Facebook, to what have you. So those connections will show where they are going through, which connection mark they're using, and that clearly shows that there's a distribution. Of course, it's not perfect. It's not a perfect 50%, but it shows that there's equitable distribution of 1, 2, and 1, 1 traffic between those two connections. Furthermore, you can again look up the actual interfaces. So if your 1.1 say was Ethernet 1 and your 1.2 was Ethernet 2, you basically click on those interfaces, look at the stats tab, look at the traffic tab, sorry, and you should see live traffic going through those interfaces. That will give you confirmation that my load balancing is working, that both my gateways are sending out traffic. Otherwise, it could just be one that is working. Then for good measure, I just did a speed test and I had some improved speeds, if I say. Now there are considerations that you could take depending on the circumstance of your setup. One of those is hotspot. If you're running a hotspot, you can visit this site here. It has a small tweak that you might have to do to make sure that your hotspot runs properly with the load balancing. Then you can add as many more. You can add another 1 connections if it's available. You just need to tweak a few things like the PCC, which is the most important. You need to tweak the PCC, then again follow through with the marking traffic from the public, and then marking traffic, adding the route marks, and then update the routing table, and then you'll be up and running with your 3 internet connections. Yes, basically there's a lot of resources that could help you. You don't have to, I didn't get this off head. You can look up all these resources from the MikroTik wiki to different other people that have done this before, and you'll be good to go. Before I take the questions, I'm going to briefly request that I run through the portal that I promised to show you guys. Then we can have a question or two. So like I said, in Uganda, some of the biggest deterrents to people buying the MikroTiks, especially for home, for small office, the Soho versions, is that they complain that they can't block stuff easily. He wants to block social media, Twitter, Facebook, and what have you, YouTube. And when you try to take him through the matching stuff and all the things that are involved, you just see a frowning face, and you even give up before it starts working. And from there on, before he even leaves, you know that he will not get it working. So the idea here was that we come up with some sort of portal that uses a click. It's basically a click tool that someone wants to block Facebook, clicks on Facebook, and bam, the Facebook is blocked. They want YouTube blocked, they click and it's blocked. They want it unblocked, they click and it's reversed basically. And so we came up with this. The login stuff is really the same. Whatever IP address you gave your MikroTik, if by default it will be the 88.1 and then the username and password. And then you could do a few other extra things, but the main thing was the blocking, but you can also limit connections and limit a bit of bandwidth using simple queues. And then the catch was that if you haven't purchased your router board from MikroTik, and this is for all offices, whether Kenya or Uganda, the portal will not work for you. And this is the interface basically. So the red implies that that particular thing is blocked. The green, it's working. Then you can type any web address, whether HTTPS or HTTP, and you click the block and it's blocked. The reboot there is sometimes if your router has been running for some time, the clients already have their cache, so they can already resolve direct to whatever site they were on. So one way to force them to refresh the cache is just reboot the router and then they reconnect and then they can't access. Then this gives you a list of what is blocked and then you can remove. Then with me here I have a small map light that I'll use briefly to show you the interface. Okay. So, like I said, my map here is in default, so I'll just log in. Now, of course, you need to be in the network of the MikroTik to do all this. So this is how it checks that you didn't purchase. The spinning part is it checking that you purchased your device from us. And then this is where you can do the whole connection limiting. Or the bandwidth by specifying the upload and download. And so what happens is we get the settings updated down here. Then you can also see the clients that are on. Currently, it should be only me. Then the blocking, it gives you that nice grid of apps that you can block. Then the rest of the websites, you can just type in here. So if for some reason I don't want people to go to the MikroTik website, for whatever reason, if I spelled that right, and it will be blocked. Then the rest are just clicking. So this is a way simpler way for people until they get used to the hardware at least, or they learn, or they invest time to know how to block themselves. That is if they want anyway. And basically that's it about the portal. The rest of the pages are really about getting in touch and about simplify network switches. Not that crucial. All right, so back to the load balancing, or even the portal. If you have any questions, briefly, 2 or 3, then yes.
I have a few questions about Simplify Network. When you want to block, for example, you want to block people from using Facebook, but during working hours, maybe from 8 in the morning to 5 in the evening, how do you do that? And then maybe unblock later after 5?
The simple answer to that is you could do a scripted timer. You can have the MikroTik supports scripting that is scheduled, so I can have a script in there that is scheduled to run and then run again at some point. So if I want blocking from 8 a.m. to 5 p.m., the script will run and activate the blocking. Then at 5 it will run and remove that blocking. So basically that is the simplest.
Do you have that in your explanation, like on your website?
On the website, not really, but we have a count at the back. We can give you any assistance any extra assistance that you might need about that, because it's hard to cater for every possible question out there when you're preparing these kinds of things. Yes.
That's okay.
All right, thank you. Yes, Michael.
Just in relation to what he asked, I think the feature he's asking about is very important. If you could just script it, because some people are even wondering, what is this scripting? Because this solution is mostly for non-technical kind of people. You're giving it to end users, for companies that are not even trying to employ an IT manager. So they want just, can you show us how it works? When you start talking about scripting, some of us understand scripting because we've been in this industry, but for them, they don't. So it would be easier just to add it as an option that, hey, I want to block Facebook maybe from 8 to 1, then give them an hour then to use it from 2 to 5. Then after 5, they can have a good time having Facebook or whatever service they're trying to block. I think
Thank you. Yeah, so this is the first iteration. We shall be making several changes, surely. All right, thank you so much for... Yeah.
I'd like to add one thing. Can you go to the presentation of load balancing?
Okay.
And go to the slide where we are going to mark the routing.
Just a minute. The slide with?
Mark routing. The slide in which we are. Timers, go. No, next one. Yes.
This one?
Yes, I'd like to add one thing. Connection mark. Yes, I'd like to add one thing over there, if you don't mind. I think so. Well, I have worked on it. Over there, we have to check the pass-through at no, because the basic agenda in load balancing is we have to mark the routing. And when we have marked the packet with a routing mark, then we do not have to pass through it. We do not have to pass through the other rules. So it should be get out from the mangling. When we are marking the routing, we do not have to go to the other mangle rules, because this
part,
yes, if pass-through is yes, it will go for the other mangle rules. Yes. So we don't have to go for this. If the routing is marked, then packet should go out from the mangle.
Yeah,
so
I get
it
you.
should be no.
I get you.
It will be helpful for some other persons. Yeah.
Okay.
Okay, thank you very much.
All right. Thank you. Thank you.
Okay.